Can you see my screen?
Yes, sir.
Okay, I have this terminal open. You can see the terminal, right?
Yes, sir.
Okay, cool. So yeah, so basically we will revisit some of the things that were discussed in the lectures this week, including strings, 2D arrays, and functions. This is giving me a notification. Okay, yeah. So let's start. So today we'll look at what are called palindromes. So basically, a palindrome is it's the same in one direction and the reverse direction. So Anna is a palindrome because this A is the same, N is the same. Civic is a palindrome, level is palindrome, and so on, right? So let's start with writing a palindrome program. Um, so we have a character array string of size, then we ask to input this, and then we check, we first calculate the length. Right, so we calculated the length of the string. Then we want to verify that it is the same backward and forward. So we'll just start iterating on the string, and if string I is not equal to string len -1 minus I, then we will print that it is not a palindrome. Otherwise, and we will return, otherwise we'll return that it is a palindrome. Right, so hope this program is clear. So basically we took an input of the string, then we calculated the length of the string. So to calculate the length, we keep iterating on the string until it has a 0, which means the string has terminated. And then we check whether it's each character at every position is the same with the reverse counterpart. And if not, we just print it's not a palindrome. Otherwise, we print it as a palindrome. So let's see if this works. If I say hello, then it says not a palindrome. If I say madam, says it is a palindrome. If I say Anna. Okay, so this program seems to be working. Cool. Any questions in this one?
So I had a question. So null character is also considered Boolean false or true?
Yes, null character is considered false. So if you look at your ASCII table, null character has a value of 0, right? So this is basically equivalent to y is 0 for null character, right? So then basically when it is y is 0, that's when it comes out of the loop. Okay, any other questions?
Excuse me, sir.
Yeah.
Sir, if we enter a string in which zero is a part of that string, so will that while loop not become false before reaching the end?
Okay, yeah, that is a good question. So you are saying, let's say the string is 0, 1, 1, 0, right? Let's say the string is 1, 1, 0, right? So if it came out a while loop here, or to make it more interesting, let's make it right. So if it came out of here, it should print that it is a palindrome, right? Because 1 2 3 2 1 is a palindrome. But if not, it should print it is not a palindrome. And indeed it prints it is not a palindrome. So what happened is basically this is coming out only for the null character, which is when the ASCII value is 0. For the character 0, I don't remember its ASCII value. We can actually print it.
It's 32 maybe.
32. Okay. Okay, this is printing 48. So I think it might be 48.
So 32 is for the space character, I think.
32 is for space. Yeah, you are right. So 32 is for space. Yeah, 32 is for space and 48 is for 0. So basically when strlen is 0, then it is equivalent to while 32, right? And while 32 is going to continue. So 0 is a different concept, like 0 as a character is different than null as a character, right? Because they have different values. Okay, any other questions?
So sir, 0 character will be evaluated as true.
Correct. Exactly. So if 0 was evaluated as false, as we saw in this program, this should have printed it is a palindrome, right? Because everything before it was a palindrome. But because 0 was evaluated to true, it printed it is not a palindrome. Okay, cool. So now let's move to this other thing. So we did this one. So let's say we want to check for a palindrome containing spaces, right? So let's try this out. Was it a cat I saw? So first of all, this is a palindrome, right? So W, W, A, S, S, then I, and T, T, A, and C. So this is supposed to ignore the spaces. And then it is supposed to say whether it is a palindrome or not. So obviously we didn't write our program that way. So it is printing not a palindrome. So let's first print the string that we are receiving. Right, so I am inputting this string to this program. And the input it actually received is just was. And it tried to check whether this is a palindrome and it failed. So we looked at this in the lecture as well, right? Can anyone recommend how to take the whole string as the input instead of stopping at a space?
Yes.
So we add an argument before %s.
Right, so we say that keep taking input until a new line character, right?
I think there's a dot before the slash. Or like either like that's what they wrote in the lecture. That was either a dot or a slash, like that's what they meant.
Yeah, let's, okay, yeah, I missed something. So slash n %s. What am I missing? So dot is for saying that when you see a full stop, then stop it. But we don't.
Yes, sir.
We don't care about full stop right now. Is this
Sir, the percent has to be before the, yeah, yes, sir.
okay? Okay, yeah. Okay, so now this is taking the whole thing as an input, so that is good, but it is still printing not a palindrome because it is getting messed up around spaces. So for example, if it was and saw, then it will print it is a palindrome. But in this case here, IT did not have a space, and here IT have a space. So that's why it is getting messed up. So any ideas like how to fix that?
Sir, we can copy all the non-space elements into another string. Then check that for, like, is that a palindrome?
Okay, yeah, that is one idea. Any other ideas? So that is a good idea, but the downside of this is like if the string is really, really long. So let's say this is a DNA sequence or whatever, which can be like GBs of string. Right? So your DNA sequence is very, very long. So in such cases, you don't want to copy stuff if possible, because you will have to use double the amount of memory.
Sir, we can use a for loop and we can add a condition that if it is a space is entered, then we will ignore it in the character array.
Okay.
And we will not take it.
So help me write it down. So you are saying if stri is equal to space, then what should I do?
Then sir, you should
Sir, we can use another variable.
Okay, yeah, that sounds good. So basically, let's say I call I as forward. And I use another variable called backward. So one variable is going forward, another is going backward. And this starts from 0, the other one starts from len minus 1. And we continue until forward is less than backward. And we move forward in the forward direction, and we move backward in the backward direction. And then we say if str forward is a space, then I'm going to increment forward so that I ignore it. And then I'm going to continue. I shouldn't continue now. And then I'm saying if forward, if backward is a space, then I should skip that. And then I check if forward and backward are the same. I think this should work. So let's try this out. Okay, this is working.
Sir, but this will work only if there is only one space between the words. I mean, if there are two spaces, then it will not work.
Okay, what should I do for two spaces?
Sorry, sir, my network was lost. Did you get my point?
Yeah. So to get two spaces, we can put a while loop, right?
Even for two spaces,
yes, sir.
The next space, and again it will check that it's a space, so again it will go forward.
So in the case, so the way in the previous program, if you have two spaces, so it will just increment forward once, and then it will come down and try to check it, right? So what we can do is we can put a while loop. So now basically this will skip all the spaces. So let's try this out. Let's say was it a cat I saw. Okay, so now basically it is skipping all the spaces. So we can I should really vary the spaces here. Yeah. Okay, so I hope, why are people waiting in the lobby? Is there a way to disable the lobby? Let's see. Who can bypass the lobby? Everyone. Okay, cool. Yeah, so I hope that this should be clear. So basically, we have two iterators now. So one is going in the forward direction, another is going in the backward direction, and we keep going until forward is less than backward. And when we see a space, we keep skipping it. And similarly, in the backward direction, when we see a space, we keep skipping it. And if at any point they are not equal, then we say it is not a palindrome. When they are equal, we say it is a palindrome. Sorry? Your voice is breaking up. I can't make out what you're saying. Can you write it in chat? Oh, someone is saying font size is not good. Okay. Okay, so we'll move on. I'll respond to your query once you write it in chat. Okay, so let's move to the next part. So we have handled like simple palindromes. We've handled multi-word palindromes. Now let's say we want to handle this kind of palindromes. So these are like different, right? These are word level palindromes. So is the same as is, it is same as it, crazy is same as crazy, how is same as how, and so on, right? So the approach we have been taking so far will not work because like the same character I, so the string starts with a I but doesn't end with a I, right? So how should we do this? Any thoughts?
Should we check for each space from front and back, like till the space comes, we'll check the words.
So we go from front to back. Let's see, let me copy this. Okay, so we go from front to back. Then when we see a space, then what do we do?
So we
put a
can
condition till it reaches the space, we can just check, like that would be the condition.
Okay. Yeah, so the algorithm is we start from both the ends. Then when we see a space, then we stop, and then we compare the rest of the words. Then we come in from two spaces, then we stop, then we compare rest of the words, and so on. So this algorithm is actually pretty good because it doesn't involve any copying. But because I have to teach 2D arrays and functions, I will take a different approach. So what we are going to do is we will break down this string into words and then compare the words. So
in the method you told just now, that time means I instead of IS, it will read it as SI, no? Means,
yes,
can you
sir,
explain
like
it again?
that's the problem.
No, so yeah, what we will do is basically we will break it into words first, right? So we will create a array. So actually, how about, yeah, I just do it and then we can just.
Can you explain the method which you were telling before? This before the using of someone was telling that we will extract from the solver.
Okay. Oh. So the approach they were saying was as follows. So basically we start similar to this. We start like we had two iterators, right? So one going forward and one going backward. So in the similar vein, we have two iterators. Then when the first iterator reaches a space, the second iterator should also reach a space at the same point, right? And once it does, we verify whether everything or whether the thing before the space is the same. And similarly, the thing after the space is the same as this one. Then again, we start. When we see a space, we check whether the thing here is the same as the thing here. So if we have time, we can also code it, but intuitively, you can imagine it should work, right? But the approach that I am saying is that I'll code first because we have to look at 2D arrays. Is basically we will first break it down into words. Right, and then I'll just verify whether this string is the same as this string, and then is this string same as this string, right? So let's do that. So I'll just move it out into a different function for now, and I'll also move this out into a different function. And this should return the length, right? And this should call the function palindrome with the string, and this is taking string length by calling that other function. So we are jumping a bit ahead, and I'm introducing functions to make the code a little bit clean, but I think it should still work. Let's try it out. Okay. Yeah, so maybe before going to 2D arrays, let me just talk a little bit about this functions, how they're working. So basically, when the program starts, right, it comes to main, then it takes this input, prints it out, then it calls this palindrome function. So it goes inside this palindrome function. As soon as it goes in here, it calls this string length function. The string length function is calculating the length and returning it. The value it returns comes to this len variable, and then the rest is basically the same. So this the way these functions are called is basically this is called a stack, right? So why is it called a stack? Is you have seen stacks in your life, right? So for example, if you have books kept one above other, it's called a stack of books, right? So the point of why we call it a stack is basically these function calls are kept like books on top of each other. So when the program starts, you have only one book called main. Then you keep another book on it called palindrome. Then palindrome keeps another book on top of it called string length. And then when string length returns, we take away the top book. Then when palindrome returns, we take away the second book. And then when main returns, we take away that book as well. And the function and the program is over. So the property of stack is, so this is where it differs from your real life stacks. In your real life stack, you can basically take books from the middle, right, of a stack. But in the stacks in computer science, you are not supposed to do that, because even in real life, right, like if you have a long, big, huge stack of books, and if you take something out of the middle, your stack will fall away, right? So it is best if you take stuff out from the top and then you put stuff on the top. So that's how the computer stacks work. So you cannot, so before string length returns, right? So you have main, palindrome, and string length. Before string length returns, you cannot keep palindrome out, right? So you have to first take string length out, then take palindrome out, and then take main out. So it is called last in, first out. So the thing that came last, so string length came last, has to go out first. Last in, first out. So does this make sense? Any questions on functions? No questions. Okay, great. No questions. So we can move on. Cool. So let's go back to the program that we were writing, right? So we are going to break this string into words, and we are going to check if the first word is same as the last word, second word is the same as second last word, and so on. So let's say we create another function called int palindrome words, and it takes a string. So what it does is it tries to break it down into words. So let's say we define a 2D array. Let's say the maximum number of words we can have is let's say 100. Let's make it 1000, and the maximum size of a word is, let's say, 20, right? So now this is a 100 cross 20 array. So this will 100 cross 20. So this will reserve 2000 bytes in memory. So now we want to break the string into words. Okay. So let's say we have the word count, the word start index. So what we do is we iterate over the string. Let's say we get the length of the string. Then what do we do is, if string I is a space, then I want to increment the count of the word. I want to put words. I want to say W start is now I plus 1. And I want to continue. Otherwise, I want to. Yeah.
So if we create a character string inside a character string, then can we compare words and then it will be better?
1 second. Let me write this down. Yeah, so say that again.
So I'm saying that, like, here we have created a character string inside integer string. Then can we create a character string inside a character string, so we can compare words at different positions?
There is no integer string here. Where is the integer string?
Sorry, not integer string, but can we do that, like character string inside character string?
Character string inside character string. So what we are doing here is trying to create an array of words, right? So we want to break this down into words. So since each of these itself is a string, so this is a 1D array itself, right? Each of this is a 1D array. And since we have an array of arrays, that's why we create a 2D array of characters.
But like if we create a character string inside a character string, so can we compare words at different positions? Like the second element of the outer character string would have the word of the inside character string.
I don't know what you mean by character string inside a character string. So string is just a sequence.
Yeah, I mean like a string array of characters inside a string array of characters. So like we have a character brackets and then another character array.
So you are saying character, just trying to understand. You are saying character words, let's say X, whatever, and then I don't know. Are you saying something like this?
No, like in the words array, you can have another character array. Like you can write char and then array in another array.
Char and then another array. Like
no, inside the words array, can we have another array? Inside that array.
That is what this means, right? So you are creating a 2D array. 1D array. So if you have a 1D array of string of characters, this is basically just string, right? Right. So this is a 1D array of characters. This is a 1D array of characters. And since you want to create keep many such strings, we are creating a 2D array of characters. Yeah, if this is still not clear, like you can write out what you want to say in the chat. And that way I can better understand your question. Okay, so here we basically broke the string into words. What we did was WNUM is basically the first iterator, and we started from 0. W start is the iterator keeping where should I start the word from. So initially it should start from the first letter I. Then when you encounter a space, we say, okay, so we can null terminate the word. So the word has to be null terminated. Then we can increment the count of the word. So now from is we want to go to it. Then we can say the start actually now starts from I plus 1. So the next word, when we encounter space, the next word will start from this I. And then we say continue. And otherwise, if it is not a space, then we can keep, we copy this character I into this first character I. Okay. Yeah.
So why you are putting 0, not null character?
Yeah, so remember every string has to end in null character. We can try it without the null character and see what happens.
No, sir, why we are not putting null character? You are equating it to the 0,
Okay.
not character.
Yeah. So null character has ASCII value of 0, right? So this is basically the same. Like semantically, it's the same thing. Okay. So next, let's try to print out all the words. I might have made mistakes in the program, so we will find those out. Okay, so yeah, there is a mistake, right? Like hello is only hello got printed. So let's see. Yeah, the last one does not have to end at a space. So we need to increment our WNUM plus plus. And we also need to equate this to 0 len minus W start. Okay, great. So far we have been able to break down this string into words. Is this clear? I think it's a little bit complex. So happy to explain again if this is not clear.
Yes, sir. Please explain.
Yeah. So basically what do we want to do, right? Like this is a string that is given to us and we want to break it down into words. So the approach we will take is we we start from here, right? And we will go forward. So when we start here, we want to copy this here, right? Copy into the first word in first index. So basically when I is 0, initially I is 0, W start is 0, and W num is also 0 when the program starts. So this is basically, and then the first letter is not space. So what this is doing is it's putting it, it's copying the first character into the first word, right? So this is doing words 0 0 equal to string 0. Okay. Then let's say we move forward. So this moves forward. And so when we move this forward, we want to move this forward. So in the next iteration, I is 1 and W start and W num are still the same. So we go ahead and we make, we copy over the first letter into the, the second letter into the second letter of first word. So we have copied IS. So this is great. Now when we come to space, so let's see what happens. So when it comes to space, we want to null terminate this word and we want to go to the next word. So when I is equal to 2, what happens? So now this is true, right? Because there is a space there. So it will come inside. And what this is saying is null terminate the I word. So the is word that we have, right? Then it is saying, let's start filling next word. So W num becomes 1. And this is saying next word starts from index 3, right? So and then we continue. So now when I is equal to 3, when I is equal to 3, W start has become what? W start has become 3 and W num has become 1, right? Then this is false, so we can ignore this. Then when it comes here, what it does is, since W num is 1, I minus W start is 0 and STRI is 3. So what this has just done is this copied this I into this next word. First character I is copied now, and then so on. Yeah, I think, yeah, this is quite complicated. Is this clear now? Better than before, at least?
Yes, sir.
Yes, sir. Better. Better.
Yeah, so you can, I will share the code. You can work it out on paper to see like how this is working, but basically we keep moving forward. When we encounter a space, we know that we have to start a new word, right? That's why we do wnum++. And we also have to reset where to start the copy from. So we don't want to copy all the way from from the beginning, right? So we want to copy from the start of the word. So that's why we set w start equal i+1. And then when it is not a space, we just copy. So this is done.
So just one confirmation, like, did you say that like once we receive space, then we'll have to even give it a null character to make that part a string? Are we making it a separate string altogether? Like, will is become a separate string?
Yeah, is a separate string altogether. Correct.
So like, where are we giving it that null character? Like, it should have a null character.
This is where we are putting the null character, right? So basically, when you see a space, here, when you see a space, right, you want to end this is with a null character.
Yes.
If you don't do this, actually we can try it and see what happens, right? So I'm not ending my strings with null characters, and I am going to rerun my program. Right, so this is ends with all this random stuff.
So does it take garbage values, like whatever would have been ahead of it, because null makes it stop taking value or something?
Null makes it stop. So sometimes we are seeing that sometimes it is okay. So basically this is the behavior of printf, right? Like even your printf is written like that. So basically this is how printf should also be written internally. So it is just going over the array, and this is waiting until you receive a 0 and just printing one character. So if you don't null terminate the string, it will keep on going until it and print garbage values until it sees a 0. So that is why it is important to set the to make it null terminated.
So, but like you equated to 0 and you said because it's the ASCII code of null is 0, that's why you equated and it's fine. But like, how does it know if it's like if we are actually trying to equate it to a normal 0 and not a ASCII value? Like, how do you differentiate between that case?
So normal
would you put quotes?
Yeah. Yes, exactly. Normal 0 is written like this.
Okay.
Yeah.
That would be like a string itself, like a part of a string, then it would be.
No, so this is single quotes. Single quotes is for character.
Character.
Yeah.
Okay.
Yeah. Cool. So we have broken it down into words, and we have already created some functions, and we are in the depths of 2D arrays. Okay. Let us now write the palindrome logic. So palindrome logic is what? We want to make sure that this string is same as that string, and we want to keep coming from both sides. So to simplify this, we will just first write a simple function that says whether two strings are equal, and it takes two strings, str1. And this is supposed to return whether the two strings are equal. So we will define true as 1 and false as 0. Okay, how do we make sure two strings are equal? How do I write this?
Can we use string compare?
No, so we could, but we are writing it on our own. Right.
Then we'll have to traverse.
So we will write a loop that will go from first character to last character and check for both the words.
First character to last character. Yeah. So what we can do is we can just keep going on until they are the same. right? If one of them is 0, so this means both of them are 0, right? So we found the null termination, so we can just return true, I++. If we ever come out of the loop, then we know it is false, right? Right, this should work. Should make I = 0. Okay. So now I'm going to use that function to do a logic, which is basically I will start from 0, then go over all the words, and I will make sure if str equal words I, words w num -1 minus I. So if these strings are not equal, right, I can just return false, that it is not a palindrome. Otherwise, it is a palindrome. It is a word level palindrome otherwise. And here I can also print why is this complaining? Let's see, can you match all the brackets? And I can also print okay, so let's run this. Yeah, so this is saying it is a word palindrome. And if I say hello world, saying it's not a word palindrome. Okay. So as we can see, like this is a program that had 2D arrays, that had functions, strings. So in retrospect, maybe I picked a too complicated program here. So we can use rest of the time to like discuss this actually if something is not clear. Yeah, so one thing I also want to do is let's say I want to, so this is a complicated logic, right? Let's say I want to move this in a different function called break words. So any idea like how, so I can just copy this over. And I can just call this break words, str words, and then I can say num is this. So I hope you can appreciate the functions, right? So the point of functions is basically when you're looking at palindromes. So there are many things we had to do. We had to break it into words. Then we tried to print out all the words. Then we tried to loop over in forward and back. So we wanted to loop and check whether the words are the same in forward and backward direction. So by doing functions, what we have done is we have made this program much simpler than if you were to not use functions, right? So by doing this, you can just imagine, okay, this is breaking the string into words. Like if you're reading a big code, then you can not. So in this case, we can ignore understanding break words. If we want to understand palindrome words, we can just say, okay, so this is going to break the string into words. And then this is printing out all the words. Then this is going in the forward and backward direction and checking whether these words are same or not. So by doing this understanding palindrome words logic has become easier. Because we have to read less amount of code now. And there are other benefits, like by using functions, you could reuse the same function from multiple places. So if you have like repetitive code, then you can just make a function for it and call it from different places. So now you don't have repetitive code. So your overall code size is smaller, and that makes it easier to understand. So any thoughts, comments on this? Or if something is not clear, or nothing is clear. Yeah, I think it's a more complicated program. Yeah. Say that again. I didn't follow your question. Yeah, what about it?
So that line I minus W start.
Okay, this one I minus W start thing.
Yes,
Do you want me to explain this again?
Yes, sir.
Okay, cool. So this is break words. So what this code is doing is, right, you have this whole string. Unfortunately, I don't have a whiteboard here. But yeah, let me try. So basically we have this whole string and we want to break it down into words. So what this is doing is it's starting your cursor from the beginning. Right, so we can write down. Actually, let me see what is the best way to explain this. So we need 3 cursors, right? So one cursor is we need 3 cursors, right? One cursor is moving on the string, right? So this is your I is just moving on the original string. So this is your I. Then you have W start, which is keeping the start of current word in string. Right, so let's say somewhere in your program your I is here. So okay, let me just represent it with different things. So let's say I is being represented with just I. W start is like this. and then we have w num, let's say, which is this, keeping the word in the word array. So let's say your I is here, right? Then your w start is basically here. So w start is keeping where the word is starting from. So when you're inside this word crazy, your I is, let's say, pointing to this Z character. Your w start is always pointing to the start of the word, which is C. Okay, then your w num is basically which word you're writing to. So in this case, your w now, not to be confused with inside the second array, but basically w num is going to be 0, 1, 2. So that we are writing it to the 0, 1, 2, which is the third word, right? So this is how the code is working. So your I keeps moving forward. As soon as it sees a space, it moves. It has to move this star to next word, right? It has to, let's say your I has come to this space, right? It has to move this w num to the next word. Then it has to move this, yeah, w star here, which is I plus 1. And then we basically start copying. So when we copy string I into I minus w star.
So I goes to the end of that word.
Yeah, so I is just moving on the first string, right? So I will keep moving. So let's say when I is, so let's say I here,
Sir,
right? Yeah.
sir, actually here we can use that when the character is space, then we can use a variable. Suppose f equals 0, and after that for each iteration f plus plus, that will also do, and that will be easy to understand for others as well, I guess.
That is right. You are saying f plus plus, right? Is supposed
No, means for the index of words, for the index of letters of the words, we can use like that instead of I minus W start. That will be easy.
Okay, okay, okay.
You got it?
Yeah.
Yes, sir, that I was telling you.
Okay, so let's try that. So the other suggestion is basically instead of doing this, what we can do is words w num w start is stri, and then instead of setting it to I plus 1, we set it to 0. So let's see, this should work as well.
And sir, increment also W start plus plus after the if one, after the if else statement.
Right.
Yes.
Okay, great. Yeah, this is indeed easier to understand. Um, Okay, so let's call it instead of w start, let's call it wi. Okay, great. So so the suggestion is basically instead of doing all this arithmetic, we will use another variable wi, which is just cursor in the word string. So when you see a space, we make wi to 0 because basically we want to write it from the beginning of the next word, right? So we make wi to 0, and then when we copy, we copy it into wi, And every time while we increment I plus plus, we are also doing wi plus plus. So actually in continue, this should be -1. When we continue after the space, we want wi to become 0. So that's why we make it -1, I think. Let's see. Okay, yeah, this was something else I wanted to discuss, but we can discuss this in a bit. Okay, so our code is still working fine. So yeah, this is indeed much simpler to understand. Thanks for that comment. So basically, forget about W start. So basically, WI is starting of the index from starting. So when you see a space, right, you want to start writing to the next word from the beginning of the word. So that's why we are saying we want to start writing to the next word. That's why we do wnum plus plus and we reset wi. Now, why do we do -1 here? Is because after you do continue, wi plus plus will become 0. So basically, you are setting wi to 0 when you see a space. And when you don't see a space, you just keep copying from wi to string I to wi. Okay. I hope this is clear. Any other questions? Yes, you will get this code.
Sir, please show the main body again.
Okay, main is just taking the string input and calling palindrome words. Okay, so I have a couple of questions. Maybe you can help me answering those. So in this case, like we sent the words in the argument. So instead of this, like I could have also tried to do something like this, right? So we'll ignore wnum for now, but I could have tried to do something like this. Right, so instead of passing it words, I am getting back the words. Let's say. Something like this. Now, would this have worked? Like, or and then eventually, so don't worry about return wnum, but the concept is basically if we try to return an array, does this work? Like, or why intuitively speaking, why or why shouldn't it work?
Sir, I think it should.
It should work. Okay, I guess I heard a yes, but yeah, so basically this will not work. And the reason for that is, remember the stack, right? So the way the stack works is when you call a function, you put a entry in the stack, and this is called a call stack, because you are basically making function calls. So in your call stack, this words is allocated inside break words, right? So the words are some memory inside this stack location. Then when you return it, you're returning a pointer to here. So you are saying, okay, the words array starts from such location and yeah. And then when you return it, this tag goes away, right? So now you have a pointer to a memory location which no longer exists. So in such cases, it will either get it can either get a garbage value or it can get segmentation fault and stuff like that. So you need to be very careful. Actually, C will disallow it in the case of arrays, but when we study pointers and stuff, you need to be very careful around around such issues with the call stack. So think of everything inside this break words. So this is the break words function. Everything inside this break words function will not be available to palindrome words function, because when it returns, the all the memory inside here is deleted or given to some other function, or OS is free to do whatever it wants to do with it. So be careful of that. The other thing, other interesting thing, if you noticed, was when I call this string, right? I don't have to specify a size here, but when I call this words, I have to specify this second size here. So let's verify that. Like if I don't, what happens? Right, this is complaining. I don't know how to handle this, right? But if I give it W size, then our program works, right? So intuitively speaking, like what you know of arrays so far. So array is just a contiguous memory, right? So when you say give me array of size 100, it gives you 100. Give me a character array of size 100. It gives you 100 bytes. So when you say stri, it tries to go to the ith byte starting from this location. So that's how it is working. So any thoughts on why it needs this size array? It's this.
Sir, to define the space required, it needs the number of columns, because the array is stored in like row wise. So from row 0, then row 1, then row 2. Okay. Then if we don't give the number of columns, then it wouldn't know where to start storing row 1 after row 0.
So this is not storing anything, right? So remember, so like if you had a really big array and you pass it to function, if it was copying the array, then that function will be really slow, right? So again, remember, like if this string was a DNA sequence, let's say this is 2 GB long string, like your string is really long, then when you call any function on that string, it will not try to copy that 2 GB entirely. So otherwise your programs will be really, really slow. So what it will instead do is it will say that my string starts from here. So I can just send this location to that function instead of copying over the entire 2 GB string. So what you just said is not valid, because there is no copying going on here. So any thoughts? Why do we need this W size? How about you think about it? I think there's someone who needs me. I'll just be right back. Sorry about that. Like, why do we need this? Why do we need to pass this size? Okay, so basically, if you remember your 2D arrays, right? How are they allocated? So when I say hello, can you hear me? Okay.
Yes, sir.
Yeah. So when you say words ij, right? What does it mean? So basically, it was trying to do I into I plus j times size. Right. So in case of your 2D arrays, your memory is still a linear thing, right? Your memory has not become a 2D thing when you create a 2D array, right? So your memory is still a linear thing. So your 2D arrays are internally represented as, I'll put my first row, then I'll put my second row, then I'll put my third row, and so on. So when I want to access ij, I want to go to the this should be, yeah. So I want to go to the ith row. So I'll jump the entire size I times, and then I'll go to the j offset. So that's why when you pass 2D arrays, so compared to 1D array, right? So when you have 1D array, you can just do str plus I, right? So that's why you don't need a size variable when passing a 1D array. But for 2D arrays, so like if you passed it a different array with a different secondary size, the indexing will be all messed up, right? Because the way it is laid out in memory. Yeah.
Words I had the number of rows as word I plus j into.
No, I think it is I times W size into plus J.
That right number of I into j.
So J is going from 0 to W size, right? J is the second index. So J can go from 0 to W size minus 1. So that's why you have to multiply the first one with it. So you find out where it is, which row it is, and then you look for the right index inside that row.
Column wise.
I don't follow what your question. Can you type it in chat? Maybe? The voice is breaking.
So, but like we can also save like in a 2x2 any matrix like 2D matrix, 2D array. Like there's row based and there's column based. Those are two different kinds of ways in which we store the memory. Like over here you told it I plus base times j like that. There are two ways.
You are not audible.
Sorry, I am going to mute you because a lot of noise. But yeah, in theory, you can do in both ways, right? So in theory, when you have a m cross n, you can first allocate n and then n and then n m times, or you can do m n times, right? In theory, you can do both. But C has picked a default for you. So C is doing n m times. So yeah, like when you go into higher classes like parallel programming and other kind of courses, this actually becomes important, like how you are iterating on the array will impact your performance of your program. So if you iterate on n versus if you iterate on m first, even though they are doing the same thing, they can give different kind of performance because how they are put in the memory. But for our
So I have one.
yeah, go ahead.
Okay. So like before like starting your explanation of breaking the string into different substrings, like what we had discussed was that we can start from the starting and end, and then we can go forward and backward respectively until we reach a space. We'll just compare it.
Yeah.
But in this case, like if we have to compare S and S, so from the left side, I'll get a I and a S first. From the right side, I'll get a S and a I. So you can't equate it like that, right? So how do I work that out?
Yeah, so what you can do is you can write a, let's say, function saying, okay, this is a string. This is my word 1 start and my word 2 start. And then I also have my word 1 start and word 1 end. Then I also have my word 2 start and word 2 end. Right. So this is basically for your, this is a long string, but let's say we have just is, right? Or yeah, so in this case, your word 1 start is 0. Your word 1 end is 1. Your word 2 start is 0, 1, 2, 3. And then your word 2 end is 4. So then you can just write this program, right? Saying, I'll just go from word 1 start. I'll just start 2 pointers, 2 cursors, word 1 start and word 2 start. And I'll go to word 1 end and word 2 end and just keep comparing characters. So then, so this is the one half of the problem. The second half is how do you find this word 1 start, word 1 end? So maybe you can try that out as an exercise. Like when you go in these directions, you can try to use the spaces to figure out how to do this. But yeah, you won't be comparing like reverse of this with this. You will be comparing in the same order.
So then directly going front and back was not the exact solution, right?
Yeah, there is more detail there, yes.
Okay. Yeah. Or like we can even reverse this string, but then it will again become a bit cumbersome. Like we can just call a function called string reverse, जो behind वाले backward function को reverse कर दे वो और जो string है उसको.
हाँ वो कर सकते हो, yes वो कर सकते हो, but वो थोड़ा सा less efficient हो गया क्योंकि now we have to like
we have another job to do.
Yeah.
Like but over here like W2 start wala, like that was what I was going to ask you when you had explained this. Like you'll have to find that again.
Right. No, so जब हम ऐसे जा रहे हैं ना, so this one is responsible for finding W2 start and W2 end, right? So basically ये पहले W2 end find करता है, then it comes back and then it finds W2 start. इस case this finds W1 start first and then it finds W1 end. तो उस तरह से करना पड़ेगा.
Excuse me, sir.
Yes.
Sir, here for the string equal function, we will first have to add the condition that their lengths are equal, right? Because here if the first 3 characters are the same for one word and for the other it will consider them equal.
In this one?
Yes, sir.
Not really. So that is, yeah. So is the way we wrote it, right? So basically this will continue until they're equal. So okay, let's take your case. So let's say string 1 is let's say IITD and string 2 is, let's say, IIT, or let's say just I. So actually, let me not pick I, otherwise it will be confusing. Let's say Delhi, and this is Del Life. So what will happen? So if you think about this is basically del I and then null terminated. This is also null terminated. So what will happen is it will first compare D. Okay, they're equal, I plus plus, compare E, they're equal, compare L, they're equal. Then it will try to compare H with a null terminated, with a null character. So this will fail and return false.
Oh, okay. Okay, got it, sir. Thank you.
Okay, there is a question, sir. Ij element can be accessed in two ways: I column size plus j row size. Yes, exactly. So in theory, yeah. So the way you are supposed to use it depends on how C has placed the memory for you. So C basically places it in the first way. Yeah. But in theory, you can build a different language that places in the second way. Why are we ignoring the spaces? So we are ignoring the spaces because we wanted to see palindrome of these kinds. Like, so basically here I and T have a space, and here IT does not have a space. So that's why we were, similarly A and C have a space, A and C does not have a space. Yes, I will give the code.
Sir, I have another doubt, but it is not related to this class.
Okay.
Like in 12th we had done C++, and there like we used to use OOPS concept to do dynamic memory allocation. But now we don't have OOPS concept, so we won't be able to use any of the classes and objects. So is it still possible to do dynamic and memory allocation?
Yes, and so far we are looking at what is called stack. So all the memory we are putting is in stack, but we will be studying a different type of memory called heap. So you can put dynamic objects in heap, and you will study that later.
In this course?
Yes.
So like one more was there, like in lectures sir had told matrix multiplication. So he had used 3 loops, like in the core of the code he had used 3 loops.
Yeah.
I was trying to do it with 2 loops, but like I was not able to cover all cases. So is there any method to do it with 2 loops, or?
So the simplest approach needs 3 loops, right? So basically, yeah. So when you multiply, let's say your A is I times J, and your B is J times K. So when you're multiplying one row with one column, you have to like loop through them. So yeah, you need 3 loops. But the best known algorithm, so for matrix multiplication, like if you have, like we have not studied order and stuff, but 3 loops is what is called NQ. So you are doing, if all matrices
Third
are,
order, right?
yeah, so it's NQ, but I think the best known is n power 2.7. So I don't really understand that, but so every couple of years people keep moving it by 0.02, 0.03, like so it was n2 power n power 2.76 for a while, then I think it moved to 7.1. But yeah, those are very involved.
Like yesterday I tried it for like 2 to 3 hours and I was not getting. So I felt really bad because
N square is no one knows how.
Impossible. Yeah.
I mean, it might
Like
be possible, but it's no one knows yet.
like I was able to get say 70% of the thing. Like there were only 2-3 places. Like if I was doing a 2x3 matrix and 3x3, if I was multiplying them, so I was getting like almost 4 out of 6 elements. Those only for catering the 2 elements I was having a lot of problem. Otherwise, 4 out of 6 elements were catered for. So I was thinking I was close. That's why I was curious and I asked because like I was only 2 spaces away. If you can get what I'm saying, like I was only 2 multiplications away to get the correct one. So
yeah, you can read more about like, but this kind of things are covered in algorithms course. But yeah, like this is a very, very important problem. Like the Google PageRank algorithm, like how they calculate ranking of pages, it uses matrix multiplication. So if you can speed up matrix multiplication, like the impact is huge. Basically, matrix multiplication is everywhere. Social networks, PageRank, like, so yeah, like if you can speed it up, it's it's quite something. Yeah. So keep trying. You are new to this, so it's yeah. But yeah, researchers have still been trying, and they move it just a little bit every time.
So, but like we can use some kind of data set as some algorithm, right, which could try to reduce it. Like if you have artificial intelligence, like isn't it possible to just
Yeah, so once you have read it, read data structures, I would like this area involves a lot of math and lot of logic. So it's a very, very interesting area if you enjoy math and logic. So yeah, you're welcome to try, but yeah, know that there's a lot of competition, like everyone in the world is trying it. But yeah, if you can do it, that's great. That's quite something.
Guys, could you just show that WI ka kaam again, like just to confirm it once, like what when you change that WI W start to WI.
Okay, sure. So yeah, so W start was running on the original string. So W start was keeping where the word starts in the original string. So when your I is, let's say, here, your I moves here, then your W start moved here. But the suggestion was, why don't we simplify it? And instead of W start, we will just keep the we'll just keep a WI, which is moving on the words array. So instead of, so previously we had to do I minus W start. Now we don't have that subtraction anymore because this dollar thing will keep moving along with I. So when your I is at this letter I, this dollar will also be at letter I. So that's what we did. We reset WI to 0 every time we start a new word, and then we copy the character from string I into this WI. So there is no subtraction involved. It's much easier.
And then we're doing WI equal to -1, and then it is again iterating, so it will become 0. So that means it's again coming to the
start of the next one.
Yeah. Okay. Thank you, sir.
Cool. Okay, great. We are out of time.
Sir, we use that not equal to sign, exclamatory sign, in that to equality of strings. Sir, please show again.
Where? Which one? Where? Where is not equal to? Here? Oh, here. This one?
Yes, sir.
Okay, so this is, so basically we are comparing word by word, right? So let's say this word is same as this word, so we move on. Then this word is not same as this word. So as soon as we find two words which are not matching, we just say it is not a palindrome and we return false. So that is why we use not equal to. Yeah. Okay, great. Thanks everyone. Hope this was useful. Yeah, I'll share this code. Okay, see you next week. Bye.
Thank you, sir. It was really amazing.
Cool, thanks.